All right, so we are in section, this is section 6.3. Last time we did 6.2 and 6.4 together. And I'm going to call this what makes a parallelogram. And another reminder, your phone should be either away, or in the holder if it's hard to keep them put away. All right, so let's look at the first two sections of your graphic organizer. So let me grab that. So what we're doing here for this first section, we're starting with a quadrilateral. All we know is that we have a four-sided shape, and what we're interested in is what other pieces of information do we need to know that we have a parallelogram. Well, the first one, two pairs of opposite sides, congruent. Then the quadrilateral is a parallelogram. So those two sides are congruent, and those two sides are congruent. We have a four-sided shape with two pairs of congruent sides. We have a parallelogram. So we'd say in symbols, if AC is congruent to BD and AB is congruent to CD, then I'm just going to say it's a parallelogram. So that would let us figure out that this thing is a parallelogram. The next one, if an angle of a quadrilateral is supplementary to both its consecutive angles, then the quadrilateral is a parallelogram. So what we're saying here is if we take angle A, angle B, and angle C. Those are consecutive angles. Those are consecutive angles. So if measure of angle A plus the measure of angle C equals 180, and the measure of angle A plus the measure of angle B equals 180, then it's a parallelogram. All right, questions there? All right, let's look at the next two. So again, we're starting with the fact that we have a quadrilateral. We want to know what we need to figure out, or what we need to be given to know that we have a parallelogram. Well, this one says if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So we're saying angle A is congruent to angle D, and angle B is congruent to angle C. So angle A congruent to angle D and angle B congruent to angle C, then it's a parallelogram. So those pieces of information are enough to tell us that we have a parallelogram. The next one, if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. I'm going to draw in the diagonals here. Diagonals go from corner to corner, across the middle. So we're saying if AD and BC bisect each other, then it's a parallelogram. So you may be given, for this one, you might be given the information about the diagonals bisecting each other in a lot of different ways. So they might say, for example, if I put point M in there for that midpoint, they might say the point M is the midpoint of both diagonals. They might say that these two segments are congruent and these two segments are congruent. That tells you that they bisect each other. So there are several ways that you can be told that the diagonals bisect each other. They might not always say in exactly that way the diagonals bisect each other. You might have to figure it out with some other piece of information. All right, we good there? Okay, the last one on the first side. The last one on the first side says if one pair of opposite sides is congruent and parallel, then the quadrilateral is a parallelogram. So we're saying, for example, AC is parallel to BD. Remember, the arrows tell us about parallel. And congruent. So in symbols, if AC is congruent to BD and AC is parallel to BD, then it's a parallelogram. So one pair of sides being congruent and parallel is enough to guarantee what we need there. All right, we good with that front side of the graphic organizer? So what I want to do, I just want to do a couple of examples. You can probably put those on the back of that graphic organizer if you want. So do a couple of examples. We'll answer any questions we have about the homework, and then we will do our activity. Next time, we're going to talk about how do we know if we have a rectangle or a rhombus. All right, so for this example, we have a quadrilateral. That's all we know about this. In this chapter, it's really important not to look at the picture and say, oh, that's a parallelogram, or oh, that's a rhombus, oh, that's a square. Go by what the information tells you. So I'm going to say this is x plus 8, and this is 5y, 4y minus 3, and 2y plus 5. And we want to know for what value of x is this a parallelogram? So we have a quadrilateral, and we have the sides, the lengths of the sides labeled. So we ask ourselves, well, if we have a quadrilateral, what do we need to know about the sides for it to be a parallelogram? For this one, we know they have to be parallel, but the numbers there don't tell us anything about them being parallel. They tell us lengths. We know that we need two pairs of sides that are the same. So we know that x plus 8 has to equal 5y, We need those two sides to be the same. And we need 4y minus 3 to equal 2y plus 5. We need both of those to be true in order for this to be a parallelogram. Well, this equation is just an equation with y in it. Once I solve that one for y, I can plug it in here, and that'll tell me what x is. So I'm going to subtract 2y from both sides. So 2y minus 3 equals 5. Add 3. So 2y equals 8. Divide by 2, and I get y equals 4. And I'm going to take this now and plug it in right there, and that'll let me figure out what x is. X plus 8 equals 5 times 4. Well, 5 times 4 is 20. Subtract 8 from 20, and x equals 12. So if x equals 12, then we have two pairs of congruent sides, and that rectangle would be a parallelogram, or that quadrilateral would be a parallelogram. Questions there? All right, let's look at one more example. So there's my quadrilateral. There are my diagonals. I'm going to call this A, D, C, B. And I'm going to say AE equals CE. And DB equals, and I'm going to put this point here. There's point E. DB equals 2 DE. And I want to know, is this a parallelogram? And why? If it is, why? All right, so what are these, what is this telling us? Is this about lengths? Is this about parallel? Is this about angles? What is that? What are these pieces of information telling us about these segments? Yeah? So it has to do with the lengths, right? And you jumped a little bit ahead, which is fine. So this is enough information to tell us the diagonals are bisecting each other. So let me grab a highlighter. Here is AE. And here is CE. And it's telling us that those two are the same. So we know that those are congruent. And it says DB, that whole thing, is 2 times as long as this thing. So it's saying that this segment that I highlighted in kind of purplish color is half as long as the whole thing. Well, that tells us that that piece is being bisected here at point E also. The diagonals bisect each other. So what does that tell us about the quadrilateral? That's a parallelogram. And the y is because the diagonals bisect each other. So this might be how you're given the information that the diagonals bisect each other. It doesn't say the diagonals bisect each other, but that information tells us that they do. All right, questions there? Okay. Our homework. So I'm going to answer questions about the homework we got last time, and then we have a short activity that we're going to do. So 372, number 8 through 24 even is the homework.